Hello, this is Chuck Ridgway, Automation Technology Manager at Horner. Thanks for joining us for another Tuesday live stream. We've got some good content for you today. Here it is, integrating the Kuebler IO-Link Encoder. Now, several weeks ago, I was at the manufacturing show in Grand Rapids, Michigan, and I had the opportunity to meet the guys from Kuebler. Now, I hadn't been familiar with them or their products before then, and they had a product there at the show which really intrigued me, and that was an IO-Link based encoder. So I thought it would be a good opportunity to show how to integrate an IO-Link encoder while also kind of introducing you to the folks at Kuebler, because I hadn't really been familiar with them before the show. Now, today I am flying solo because we pre-recorded this video. Later this week, we're doing IEC training at the factory, and I want to get ready for that. But even though this was pre-recorded, we are streaming it live on Tuesday, and we have folks standing by to answer any questions you have in the chat section. And if you're watching on replay, give us those comments and questions in the comment section. All right, let's take a look at how we're breaking down today's topic. We're going to start with a quick IO-Link review, and then we're going to go through what some of the typical encoder interface options are when you're integrating an encoder with a PLC or with a Horner OCS. Then we're going to stop and take a few minutes to meet the guys from Kuebler USA and hear what they're all about. And then it's all about demonstration. We're going to go through the setup process, and we're going to show you how we get that Kuebler encoder over IO-Link communicating with the Horner OCS. All right, here we go. All right, let's do a quick IO-Link review. First of all, IO-Link is not a Fieldbus. I know a lot of us kind of think of it that way, but it's not a Fieldbus. But it's often used alongside a Fieldbus. IO-Link differs from Fieldbuses in that it features point-to-point communications. Pretty much all Fieldbuses that aren't Ethernet-based are pretty much a multi-drop type architecture, if you will. Now, the whole goal of IO-Link is to really improve the integration of sensors and actuators and other smart devices with automation systems. And it's really grown in popularity because of the successful way it has accomplished that, and especially the way that it has accomplished kind of saving complex configurations for smart sensors and making those much easier to maintain over time by keeping the configuration of those sensors in the IO-Link master, which means swapping out a smart sensor in the future becomes just automatic instead of potentially a long process of reconfiguring a smart sensor. Okay, the advantages of IO-Link are many. I already mentioned storing the device configuration in the IO-Link master to make swap out of smart sensors easy. Another big improvement is the fact that there's a lot of field configuration that can be done. So instead of ordering really a custom sensor to your specification, you can make about all the adjustments you could ever need in the field and buy something off the shelf. Now let's talk about encoders. Encoders convert motion to an electrical signal that can be read by a control device like a PLC or a counter or a Horner OCS. Now, the feedback signal is sent by the encoder, and that's typically used to determine position, but it also can provide data such as speed and direction as well. And then encoders can either be incremental, in other words, they can send pulses or signals out that indicate a change in position, or they can be absolute and send out a value which represents the absolute position in actual numbers, for instance. Now, typically, when you integrate an encoder, there's a variety of ways you do that. So with a Horner OCS and with PLCs, really, the most common way to integrate an encoder is through a high-speed counter. So in that scenario, you would purchase an encoder that typically would have, some sort of quadrature interface. Electrically, it's usually either a line driver or some sort of push-pull or totem-pole type output. And then the signals that are going to be output by the encoder in that scenario are typically going to be A, B, and then sometimes Z. Z is what's called a marker signal, and it's on once per revolution, but it's not used in all encoder applications. Now, another way of integrating an encoder is through a Fieldbus, and a very good one to use for encoders is CANopen. And CANopen is a good Fieldbus for encoders because the way it's been designed, it does extremely well with time-sensitive data, It does extremely well in motion control type applications, and really encoders are very often used in those sorts of applications. And of course, IO-Link is what we're going to talk about today. And in that scenario, we're going to utilize one of the new IO-Link masters connected between the Horner OCS and a Kuebler IO-Link encoder. All right, let's take a few minutes and let's meet the Kuebler team. Okay, so to talk about IO-Link encoders, we're going to bring in the guys from Kuebler, starting with Mr. Ed Toller. How are we doing today, Ed?
Doing well, Chuck. Thank you.
Great. Now, why don't you tell us about Kuebler and tell us about what you do there?
Kuebler is a second generation of manufacturing encoders, slip rings, and counters. We're in 55 countries. We have 560 employees. And like I said, our main focus is encoders and the new technology going forward.
That's cool. So how long has Kuebler been making encoders?
We've been making encoders since the early 90s, and we keep progressing our technology as well as our protocols every year.
Excellent. And you've been supporting IO-Link since?
Since 2018.
2018. Very good. All right. Thanks for that, Ed. Okay, so next we're going to bring in part of the Kuebler application team, and that is Kevin McLaughlin. How are you doing today, Kevin?
I'm doing well, Chuck. Thank you.
Terrific. Now, what's your role at Kuebler?
I am the lead applications engineer for the U.S. and North America.
Excellent. And where are you guys based?
Based out of Charlotte, North Carolina.
Excellent. Sounds good. And kind of your experience base is probably mostly in
manufacturing and factory automation.
Okay, very good. Probably a lot of OEMs and end users that you sell to, I would imagine, correct?
Yeah, mostly OEMs.
Excellent. All right, and then finally, we have our third and final, certainly not least, member of the Kuebler team that we're talking to today, and that is Dayton Hall. How are we doing today, Dayton?
I am doing great, and yeah, truly a pleasure to be here.
Excellent. So what's your role at Kuebler?
So I actually work with the sales team. We focus on, it's more of an exploratory position where we're looking for new applications, new industries, while we're working with current customers and finding those niche markets that we like to be in that we can serve.
Excellent. So for our viewers out there who maybe after watching today's program become interested in purchasing one of your products, how can they go about that?
Absolutely. Great question. We try to make it simple. We have just general contact information on the website that is monitored by multiple personnel in our Charlotte office. And then from there, it gets distributed to the correct person in your area. We go geographically. So either you're going to be working with Ed, myself, or any one of our sales guys.
Outstanding. Sounds great. Okay, well, again, thanks for joining us today. And I'm really excited to be working with your product.
Likewise.
All right, now, Dayton, before I move on to one of the other guys, why don't you give us a quick overview of your product line?
Absolutely. So as Ed mentioned, we have three main product lines. In position and motion sensors, we have rotary and linear encoders. We support a wide variety of protocols, from your traditional incremental to your absolute protocols. On top of encoders, we have inclination sensors to measure either single or dual axis measurement. Then we move to slip rings. Slip rings are mechanical devices that allow for transmission of electrical signal, power, or a medium fluid, water, oil, liquid, from a stationary platform to a rotating platform. Again, it's more of a mechanical device. And then thirdly is our display side of things. So that includes a wide variety of counters, hour meters, process devices, controllers to allow to display position, and then transfer that to, say, a PLC or a controller.
Outstanding. That's a really nice overview. Again, thanks for that, Dayton. Okay, now I'm going to bring in Kevin again, our application guru from Kuebler, to talk in a little more detail about those IO-Link encoders. So, Kevin, can you fill in the details for us?
Yes, gladly. We have, with the IO-Link encoders, we have three variants, and they come in both single and multi-turn capabilities. We have a 36 millimeter mounting shafted encoder, a 36 millimeter hollow bore encoder with a blind hollow shaft, and a 56 millimeter mount encoder with a shaft. They max out at 14-bit, up to 14 bits on the single turn side on both the single and multi-turn. And with the multi-turn encoder, you can get up to 18 bits of multi-turn data as well with that.
Nice. Okay, so obviously, I'm sure you support more than just IO-Link type interfaces on your encoders. What are some of the other options customers have?
Yes, we also support CANopen, J1939. We also have industrial Ethernet with Ethernet IP, Profinet, and EtherCAT. We also have ProfiSafe encoders as well for safety needs.
Wow, that's quite a lineup. So very impressive. Thanks for that. All right, we're going to bring Ed back in. I've got another question for him, question or two. First one would be, what industries or applications have you sold these IO-Link encoders, or maybe just your encoders in general?
Yeah, there's lots of different directions to take IO-Link. For Kuebler, one of our biggest ones is factory automation and anything that surrounds that. The other one is wind and power is another big one for IO-Link. But to his point is, whatever turns and needs positioning is where you use these encoders.
That makes a lot of sense. Now, what do you think is really the big customer benefit to using an IO-Link based encoder?
Well, an IO-Link is an open protocol, so it can be used with any PLC that offers that.
Mm-hmm.
It's a lot less cabling with a 3-wire system, and then you also have a simpler setup.
Outstanding. Yeah, those are some real benefits. I can definitely see that. One of the things I think people don't always think about is the cabling being straightforward and less expensive. So that makes a lot of sense. All right, I'd like to thank the guys from Kuebler for joining us today.
Chuck, we'd like to thank your time for putting this on today. What you and Horner Automation are doing with IO-Link and the controls and with our encoders, it's going to be really neat to see how the market responds and goes forward with this. We appreciate your time.
Thank you for having us, Chuck, and we look forward to seeing where we progress with Horner Automation and IO-Link.
Chuck, no, thank you very much again from our side. It's always a blast networking, meeting people at shows and events, and being able to come back and continue conversation. So again, thank you very much from our side.
All right, now it's time for the meat and potatoes of today's program, and that is the integration of the Kuebler encoder over IO-Link to the Horner OCS. All right, let's talk about what we're going to need at configuration time. All right, so the first thing we're going to need is the free Banner IO-Link configuration software. Remember, the IO-Link masters that Horner sells were manufactured by Banner, and we utilize the same Banner configuration software that they created. Next, you're going to need the IO-Link configuration adapter. That's that Y cable you see there on the center of your screen. That's going to allow you to configure both the master as well as the encoder. And then you're going to need to download from the Kuebler website, you're going to need to download the IODD file, which is the IO-Link file for the Kuebler encoder that you're using. Now at runtime, what you're going to need, of course, any modern Horner OCS. All the modern Horner OCSs support IO-Link, or they support the IO-Link masters. You'll need one of the IO-Link masters. There's a 2-channel version and a 4-channel version. You're also going to need an OCS to IO-Link master cable. It's kind of a Y cable, and you see it there kind of in the center of the screen. That's the IO-Link-MJ cable. That cable provides communications between the OCS and the master, and it also powers not only the IO-Link master, but also any devices connected to it. Then, of course, you're going to need a Kuebler IO-Link compatible encoder, which, of course, you would have had to have for configuration, of course. And then you're going to need some M12 cord sets, because one of the great things about IO-Link is that it utilizes standard M12 cord sets in a lot of cases. All right, now, we're also going to need to do a little bit of programming in Cscape and a little bit of setup in Cscape, and we'll demonstrate all that for you. But just to summarize, we're going to need to set up Modbus. We're going to do that by setting our communication parameters, setting up the data format, setting up what data we want to read and where we're going to put it in our local OCS program. And then we're going to do a little bit of data manipulation in Cscape because the data coming in over Modbus from the IO-Link master is in Word format, and we're going to need to convert that into double integer. Now let's demonstrate the process. Okay, so the first step is we are going to need to configure the IO-Link master and the encoder. So here's my connectivity I have right now. So this is the actual M12 leg of the IO-Link configuration tool. Okay, so I have that connected to the master. And then the encoder is also connected to the master. So with this setup, I'm going to be able to configure both the master as well as the encoder, because the other legs of my IO-Link configuration tool are connected to power, of course, because we need to power these two devices. And also they're connected via USB to my computer. So we can fire up the IO-Link configuration software and get everything done that we're looking for. Okay, so let's head to the computer. And I've got the IO-Link software loaded here. I will hit the connect button. It prompts me for the serial port in use by the configuration tool. COM5 is correct. Okay, now the first thing it's doing is it's telling me that the IODD file for my encoder, this is the part number for my Kuebler encoder, is not loaded yet. That's fine. That's what I would have expected to see. Okay, so let's go ahead and load the IODD file for the Kuebler unit. All right, so up in the upper left here, I hit load IODD. And now I need to navigate to the directory where I've stored my IO-Link files. So I go to my IO-Link config area here. This is where I've chosen to store my IODD files. I go to my Kuebler folder that I had created, and then I have two choices here that I found on the Kuebler website for the M36 encoder. And I'm using the standard version based on the part number of the encoder that I have. This one is the Smart Sensor Profile. I don't have that one based on my part number. I have the standard profile. And then I can go ahead and select the appropriate language. English is the default here without the extension for language. So I'll select that one and I will hit open. Okay, so it's telling me that on port 2, okay, there's my encoder connected. All right, so let's go ahead and take a look at this guy. Okay, so we can take a look here at the generic screen to see the information that's displayed here. And then we can just go right and take a look at process data. So we've got process data coming in already. All right, with our, I can go ahead and turn the encoder a little bit and you'll see we've got updates to our process data. All right, now I could also go to the parameter tab and read all the parameters, okay, for the encoder and go in and make adjustments and write parameters. But in this case, I'm going to be using the encoder in its default configuration, so I'm not going to do that for this demonstration. So I'm just going to go ahead and utilize it again as it comes from the factory, which also means, since I'm doing that, I don't necessarily have to store the configuration profile in the master for this particular port because I'm just using the standard from the factory type setting. So I won't show that either. If you're interested in how to do that, you can go back to our previous IO-Link demonstration video that we did a few months back that demonstrates that process. Okay, so that's the configuration that I've done here. All right, and I think we're ready to start sharing data with the OCS. All right, so now we'll take a look at our bench at runtime. We're no longer configuring the system. Now we're actually at runtime. So what we have now, we still, of course, have the encoder connected to the IO-Link master, but now the IO-Link master, instead of being connected to the configuration tool, it's connected to the runtime Y cable for connecting to the OCS. So this is the base of the Y, that's the M12 connection. And then one upper arm of the Y is connected to MJ2 via RS45 here. Okay, and then the other leg of the Y, other arm of the Y, I guess you could say, that's actually running off to 24 volts DC to power the master, and through the master, also the encoder. Okay, so that's what it looks like at runtime. And as you can see on my XL4, I'm currently displaying the encoder position as well as the velocity. It's just sitting there right now. So as I count up, you can see that my position is updated and my velocity is updated. If I turn the other direction, you can see my velocity goes negative when I'm turning here, and my position goes down. So, you know, that's what it looks like at runtime. Really straightforward. Next, we need to take a look at how we set this up in Seascape. Now we're in Seascape, and really, let's start with the hardware configuration, because a bulk of what we need to do here is gather data from the IO-Link master over Modbus. So let's go under serial ports, config. MJ2 is the RS45 port on a XL4 or XL4 Prime. So I've configured that for Modbus master, because that's how we're going to communicate with the IO-Link master. And then from the network configuration standpoint, these are all the serial parameters that we're going to use. The standard for the IO-Link master is 19.2N81. Multi-drop half duplex Modbus RTU protocol. And I've reduced my timeout and my reacquire time down to relatively short numbers, 500 milliseconds for the retry and 1000 milliseconds for reacquire. If you've watched any of our other IO-Link videos, this setup is going to look very familiar, because it's pretty much what I use for most of my IO-Link projects. And then we definitely want to take advantage of the Modbus master status by assigning a 32-bit array with a dimension of 4, so that we can see what the poll time is, how many no responses, how many bad responses, and how many good responses we have. So that's what we get through our status here. I've also, in this scenario, I don't always do this, but in this scenario, I've also assigned another bit type variable that I can use to disable MJ2 if I want for some reason at runtime. But again, that's a purely optional type scenario there. On the device level, for the IO-Link master, I gave it a convenient name. It does have an ID of 1. And then I've chosen 5-digit addressing. And then I've also taken advantage of the slave status by assigning a word type variable with a dimension of 2. So it's an array of 2 words, so that we can monitor specifics on the slave as well. Okay. All right. So that is the configuration on the device level. And then on the scan list level, let's take a look. And again, this should look pretty familiar with other videos you've seen from us before. When we're polling the IO-Link master, in this scenario, I'm connected to port 2 on the master, not port 1. So I'm reading data from Modbus addresses 42,001. If I was reading data from port 1, it would be 41,001. But I'm on port 2. And then it's 17 words of data is the typical maximum amount of IO-Link runtime data that you're going to be receiving from an IO-Link device. So I almost always just assign the full 17, even though we're only going to be using a portion of that. And then locally in my program, I've got a word type array, because remember, this is Modbus, and Modbus by its standard is word type data. So I have a word type array where these 17 words are being mapped in. And again, this is a polled read, because this is read-only data. Okay, now as it turns out, the data being provided by the Kuebler encoder, there's really only 4 words of that. 2 words, which are velocity, and 2 words, which are position. So the next thing we'll need to do, this is the Modbus configuration. The next thing we'll need to do is show you how we handled the data coming in. All right, so the first thing I like to do, anytime that I'm reading in Modbus data in its standard word type data, and ultimately if I'm going to be using it as double integer or floating point, if I'm using variable-based advanced ladder, which I often do, I like to take the Modbus array that I'm mapping everything into, and I like to map that or memory map that to a fixed %R location. In this case, I just picked R10,000. All right. And that will allow me to transcribe this word type data to double word data by simply creating double integer type variables and mapping them somewhere within that memory map. So our data coming in from the Modbus master is going to be between R10,000 and R10,016 because it's 17 words long. And then the specific data for velocity is in the second and the third word. And the specific data for position is in the fourth and fifth word. That's where it's located within that map there. Now, one thing you'll notice is I've created variables with the name of velocity raw and position raw. Why is that? Well, as it turns out, the data I'm getting back from the Modbus master, or I'm sorry, from the IO-Link master, is word swapped. Okay, so I will need to swap the lower and upper words for velocity and the lower and upper words for position in order to read the data properly. So I've got a little routine here in logic, which is simply using a rotate function to take my raw data in, shift it 16 bits, and store it as a new variable. In this case, I'm taking encoder velocity raw and storing it as just encoder velocity. And I'm doing the same thing for position because that's really the data I'm getting back from the encoder. So these are the variables I'll be using in my program that I'll be using as I take advantage of the data I'm getting back from the encoder. Okay, and then to display it on the screen, it was just a simple matter of creating a couple of data fields on the screen. And then keep in mind, position is a unsigned value, okay, 32-bit unsigned, and velocity is a 32-bit signed value. So that's the other subtlety there to be aware of. All right, so that's all we need to do to get this all configured and running in Seascape. Okay, this is the portion of the program where I remind you that we're here every Tuesday at 2 o'clock, whether we're fully live or whether we're pre-recorded like today. But we always have somebody standing by Tuesday at 2 o'clock to answer any questions you may have. And if you're watching a replay, like a lot of you do, give us those comments and questions in the comment section, and we'll reply to those when we can. Okay, a reminder, we're celebrating our 10th year of Horner Lighting Group products, so check out their great videos on the Horner APG YouTube channel right alongside our automation content. And here we go for the next training schedules. I mentioned the fact that in the next couple of days, I'm going to be holding an IEC training class here at the factory, but that one's closed. Upcoming in October and November, we have a basic course and we have an advanced course. So don't miss that opportunity. Head to our website and sign up for training. Now, next week, we're going to have a fun program. We're going to spend some time with one of my favorite automation engineers, and that is Andrew Jagger from PowerMation. So you won't want to miss that conversation that we have with Andrew Jagger. And we'll also get to show off one of Andrew's videos that he did on banner safety and Horner OCS, how to integrate those two product lines. So that's definitely something you won't want to miss. Now, if you haven't subscribed to our channel yet, don't hesitate to do so. It doesn't cost anything. And if you choose notifications when you subscribe, you'll be notified every time we go live or every time we post a new video. Okay, so until next week, when we spend some time with Andrew Jagger, let's all get out there and do us some good.